Hello and welcome to Introduction to Skimmer Sediment Basins. My name is Jamie McCutcheon. I'm a 1992 graduate of Clemson University with a Bachelor's of Science in Civil Engineering. I founded CCAD Engineering in 1999 and invented the Marley float skimmer in 2013. In 2018, we rebranded from SW Products to Rymar Waterworks Innovations. I'm a licensed professional engineer in South Carolina, North Carolina, and Georgia, a member of IECA, ASCE, ASTM, and CESWA. Introduction to Skimmer Sediment Basins Objectives. This will be a short course to go over exactly what is a skimmer and why is it used, and also learn the fundamentals of skimmer basin design. We will also review just a few slides regarding the Marley float skimmer and specifics about incorporating that skimmer into your designs. There are over 30 states that currently have surface withdrawal requirements. States with surface withdrawal requirements generally do not have a, quote, approved list of devices. They typically defer to the engineer of record to specify a method or device to meet this requirement. However, many state Department of Transportations and some local MS4s do have an approved list. There are a few states that actually do have approved lists as well, but they are rare. In most states, the Construction General Permits, or CGP, have a requirement for surface withdrawal. The most common and cost-effective way to meet this is by using skimmers. Often what you'll find in the CGP is an verbiage similar to the following about surface outlets. It says, when discharging from sediment basins, utilize outlet structures that withdraw water from the surface unless infeasible. Most states go further to say that they believe that the circumstances in which it is infeasible to design outlet structures in this manner are rare. Also, some states in colder weather do have extended time periods or allow for removal of the skimmer during frozen conditions. So sediment basins with skimmers withdraw water from the surface or near the surface, allowing sediment to settle to the bottom. The Marley float skimmer takes in water from 4 inches to 16 inches below the surface and excluding trash or debris on the surface from entering the orifice. So the three fundamentals of sediment basin design are volume, time, and flow rate. Fundamental number 1, basin volume. The basin volume is based on the area flowing to the basin. Regulations differ as to total area or only disturbed area to be used in the calculations depending on your state or local MS4. A general standard that appears in many regulations is 3,600 cubic feet per acre flowing to the basin. Again, some areas will stipulate total acreage, other areas will stipulate disturbed acreage. Some other states require only 1,800 cubic feet per acre. So, for example, if you had an 8 acres flowing to your basin times 3,600 cubic feet would equal 28,800 cubic feet as your required volume to size your skimmer. Some areas also require basins to have a permanent pool volume or sediment storage volume that is not drained by the skimmer. It is critical to use the required volume and not the actual volume besides the skimmer, especially in cases where you have a multi-purpose basin that will be converted to a detention pond later. There are times when that multi-purpose basin may have a volume that far exceeds the required volume. If you use the actual volume, then the required volume will drain much faster than it is supposed to per the regulations. Fundamental number 2 is dewatering time. The general rule of sediment basins work by allowing time for sediment to settle to the bottom. The time required will vary based on soil type. Sands will settle quickly, but silts and clays take much longer. A general standard that appears in many state regulations is 2 to 5 days, or 48 to 120 hours. Other states require 2 to 7 days. Some states have a 4 to 7 day period, and other states have no standard and leave it up to the engineer. Note that engineering judgment is needed to balance the need for extended times for certain soil types versus the frequency of rain events. The basin should drain before you expect the next significant rain event, so that it does not overtop and all the water go out through the spillway rather than through the skimmer. Fundamental number 3 is flow rate. Once the basin volume and dewatering times are established, then the required flow rate range is easy to determine. It's basin volume divided by dewatering time equals your flow rate. You will use the minimum dewatering time to determine the maximum flow rate and the maximum dewatering time to determine the minimum flow rate. Once the range is determined, select the appropriate skimmer based on manufacturer's specifications of flows for that basin. For example, if you had our 28,800 cubic foot basin, if we drain it in 2 days, has a flow rate of 14,400 cubic feet per day. So that would be your maximum flow rate. However, if you would allow it to go up to 5 days, then the flow rate would be only 5,760 cubic feet per day, which would be your minimum flow rate, assuming an allowable 2 to 5 day drain time. Note that a lower flow rate will often result in a smaller and typically less expensive skimmer, which may be desirable for your contractor or client. When specifying skimmers, it is important to specify the flow rate, not just the skimmer size. Testing has been done on several different types of skimmers by different manufacturers. As an example, 3 3-inch skimmers were tested. You'll see that the test tank is 0 to 4 feet deep, and the flow rates start at 1 foot. 2 of the skimmers are very close, around 37 GPM. One skimmer is nearly double that at 70 GPM. As the flow or the depth in the tank increases from 1 foot to 4 feet, the flow rate also increases, about 25% for each skimmer. At the 4 foot depth, 2 of the skimmers are close to each other at 47 and 53 GPM, while the third skimmer is again nearly double at 90 GPM. So therefore, if you just specify a 3-inch skimmer and not the brand, type, or flow rate, you may not get what you desire and your pond may not function correctly. It is critical to compare the flow rates. You can't assume the same size is an equal for different skimmers. State sediment basin standards do vary. For example, in this chart we compare 5 different states. We're based in South Carolina, and in South Carolina the basin volume is required to be 3,600 cubic feet per acre. It is not clearly specified whether that is total acreage or disturbed acreage by the state. In North Carolina, sediment basins are required to have 1,800 cubic feet per disturbed acre. If it's a sediment trap, that's for smaller areas that just flow through stone, it's 3,600 cubic feet per acre. In Georgia is again 1,800 cubic feet per acre and is not specified clearly whether that's total acreage or disturbed acreage. Ohio requires 1,800 cubic feet per acre based on the total acreage for the dewatering zone. They also require an additional 1,000 cubic feet per acre per disturbed area for sediment storage, and this sediment storage is a permanent pool that is not drained through the skimmer. In Kentucky, it is soil type dependent and must be calculated. Surface area is fairly consistent among the states. Some states have a standard of 325 cubic feet per second based on the 10-year 24-hour storm. Other states have a formula based on the 2-year storm. When you run the math on this, they come out to a very similar requirement. Ohio does not have a specified surface area but has a maximum depth of 5 feet. And again, Kentucky requires it to be calculated based on soil type and basin ratio. The principal spillway is generally considered the skimmer, and if applicable, a riser structure. So in states vary from a 10-year to a 2-year standard for the principal spillway to be sized to handle. Most states also have an emergency spillway requirement, which would typically be a emergency spillway of riprap or reinforced turf area in the dam. This varies from a 100-year requirement in South Carolina to a 10-year in North Carolina and 25-year in Georgia, Ohio, and Kentucky. Skimmer requirements, or where a skimmer is required. In South Carolina, if it's 10 acres or more is required, it's preferred for smaller areas. North Carolina is required on nearly all sizes. Georgia is preferred, although not technically required, although some MS4s do require it. Ohio is for 10 plus acres, it requires a skimmer. In Kentucky, it's required on sediment basins of 5 plus acres. In general, any sediment basin, if you're using a sediment basin where the state has a construction general permit for surface patrol, it's required to have a skimmer. In states with larger areas, it's typically because the smaller areas are allowed to use sediment traps or other methods and don't necessarily require a sediment basin. One critical thing to maintain is dewatering time. States have a 2 to 5 day time, or in some states a 2 to 7 day time. Georgia has no standard. They leave it up to the engineer of record, and Kentucky requires it to be calculated for 80% trapping. One important thing to note is that Georgia does require skimmers to be based on product-specific testing for flow rates. The skimmer testing data shown earlier came from a study that was done by TRI Environmental for Georgia when they were updating their erosion control manual. So as you can see, basins for sediment, or standards for sediment basins, do vary among states, and it's important to be aware of the states you're designing in and get those specific requirements. In addition, local MS4s may have differing requirements. Typically, they are slightly more stringent than the state requirements if they have to meet certain standards or have certain concerns in their area. So we have developed a design aid tool. It is a very simple Excel spreadsheet. It's available on our website for free to download. So this tool allows you to input your date, your project name, location, your company name, and the engineer that's referenced. You also put in a basin description, and we've given you 2 other lines for other areas. Using your state requirements, you can plug in your required acreage or your acreage flowing to your basin and the required volume, so you can determine your required dewatering volume. Then in your calculations, we give you other inputs. You can put in the maximum time to drain, in this case 5 days or 120 hours, the minimum time to drain, 48 hours or 2 days, pond depth. Now the pond depth is what is equal to what the skimmer is going to drain. It is not the full pond depth. So it would only go up to the top of the riser structure or wherever a secondary orifice may be. The pond top length and width, and the bottom length and width. Now we understand that there are very few ponds that are perfect squares or rectangles. So you use your engineering judgment to adjust these numbers to get a calculated pond volume. In this case, our calculated pond volume is slightly greater, but within 5% of our required dewatering volume. And again, we're working within a 2 to 5 day range, so you don't have to get this exact as far as your pond goes, but you want to be within a reasonable volume. That way you'll calculate your correct skimmer size. Understand that you can't read this, but this is simply a chart that shows all of the different skimmers and orifice configurations that we have available. And this chart will calculate for each one of those what the dewatering time would be based upon your inputs. At the bottom of the page, there's a skimmer report page tab. Simply click on this tab and it will take you to, based upon your engineering judgment based on your soil type, you would select one of these skimmers to specify. You'll notice that in many cases you'll have multiple choices and you need to look at the orifice configurations. For example, the 3-inch skimmer with a 2.5-inch orifice will drain the pond in 94 hours, which is actually slower than a 4-inch skimmer with a 2.5-inch orifice. However, the 3-inch orifice or 3-inch skimmer with 3-inch orifice will drain in 51 hours, which is faster than either of the 4-inch options in this case. So again, it's important to look at the time to drain and the skimmer options to pick the one that is best suited based on your specific site conditions. And this is just a blow up of that chart just for easier ability to read it. To aid in specifying skimmers for skimmer sediment basins, we've developed skimmer sediment basin details that are available on our website at marleyfloat.com or rymarwaterworks.com. We have 4 different versions of the details. They are all available in CAD or PDF and are free to download without any login or sign up required. This particular basin is a temporary skimmer sediment basin. Temporary skimmer sediment basins typically have a barrel pipe without a riser structure and an emergency spillway. We provide a chart for your standard sediment basin criteria that would apply to any sediment basins on the site. Note that we allow you to establish a minimum and maximum dewatering time range on the detail. We give you a data block where you can put in information for different basins on the site and expand this as needed. It includes drainage area, disturbed area, Q, whether that's a Q10 or Q2 based on your basin design. The basin volume, again, your provided can be greater than your required, but you want to list the required since that's what you're going to base your skimmer sizing on. The basin surface area, make sure your provided is greater than your required. The outlet information, barrel pipe size, barrel going through the dam, emergency spillway, elevation and width, and then your skimmer size, orifice diameter, skimmer manufacturer, so that you can determine the flow rate for the skimmer that you specified. Is an equal allowed, yes or no? In most cases this will be yes, but in some cases it may be no. And then specify your minimum flow rate and maximum flow rate based upon your minimum and maximum time. By putting this on your detail during the review process, if the contractor or owner decide they want to use a different skimmer or different size skimmer, as long as it meets the range specified, it should not have to go back through a full review and simply be a shop drawing. Again, we have this version without a riser structure and with the riser structure available on our website. You can use our other design tool, which includes a permanent pool volume in areas that require a permanent pool, such as Ohio. So in this case, you have similar information here as far as your project inputs. We've added a place to calculate your required sediment storage volume, which is typically based on your disturbed area. Often that's 1,000 cubic feet per acre, but you can adjust to your local MS4 requirements. And your required dewatering volume based on your total drainage area to the basin. And again, you can adjust that the volume required based on your local MS4. In this case, we come up with 8 acres, 1,800 cubic feet for 14,400 cubic feet of basin volume. You have similar inputs as the other tool, where you have the maximum and minimum time to drain. Pond depth, in this case, is not going to include that permanent pool volume. It would be from the invert of the skimmer at the outlet to the top of the riser or spillway, whichever the case may be. Again, your pond top length and width and bottom length and width need to be adjusted as needed based upon your engineering judgment to get a calculated pond volume that's relatively close to your required pond volume. Typically, the pond depth would have very little adjustment. You would adjust your top length and width and bottom length and width in order to get an accurate representation of the pond volume. Again, we have the skimmer report page available on this. That will go to the same one-page printout. In this case, we've added your total disturbed area for your required sediment storage volume. Give it an easy check for the reviewer to make sure you've provided that. And then here you've got your required dewatering volume and noted to make sure it's similar to your calculated pond volume. And again, we're within a couple hundred cubic feet, and so that should be sufficient. You then calculate your minimum flow rate for your maximum time, your maximum flow rate for your minimum time, and again, see which skimmers are suitable for the basin. In this case, you'll see you actually have a choice of 3 different size skimmer with different orifice configurations. We typically shoot for something around 3 days. So around 72 hours is desirable. So in this case, we would probably recommend your 2-inch skimmer with a 2-inch orifice to hit a 70-hour time frame. However, if you want to go down to just over 2 days, you could go to the 4-inch skimmer with a 2-inch orifice. Note, both of these have 2-inch orifice, but because the difference in skimmer design, you have a different flow rate. One's going to drain in 70 hours, one in only 50 hours. Or you could use something in the middle of a 3-inch skimmer and go to a higher or longer drawdown time. Again, we have a sediment basin detail that covers this. We have this version in temporary without the riser structure. This shows 2 alternate locations for your skimmer. We recommend that the skimmer be installed parallel to the dam. This makes for easier installation or inspection rather, and you can verify you've got your right orifice configuration and skimmer size, and also if you do get a clog or debris, it's easier to get to it. Now, it's important to do that with skimmers that have a relatively rigid coupling that holds this in place. If this coupling connection here is too flexible, the skimmer can get stuck on the side of the dam. We have the same sediment basin criteria. We just simply add a sediment storage volume requirement. Basically everything else is similar. We added a block for the sediment storage volume and dewatering volume. Again, your required should be less than your provided, and your provided could be much greater, but you want to make sure that your design is based upon your required. Then we have basically all the other information you need for your skimmer basin design. So your riser information, your barrel information, skimmer invert, etc. Skimmer type, we filled it in for you. Here's the Marley, but you can certainly change that. And equal, allowed, yes or no. And then the skimmer flow rate, again, you want to specify that range so that if the different skimmer is desired by the contractor, it's simply a shop drawing review. So just a little bit about the Marley float skimmer in case you're not familiar with it. It is different or looks different than many of the other skimmers on the market that are typically PVC. So the Marley float is made of HDPE pipe, a polyethylene float, and stainless steel or aluminum fittings. It is UV resistant, it's virtually indestructible, and is fabricated to be part of the permanent outlet structure as well as temporary use. It enhances water quality by having a shielded orifice. Again, this debris guard on the outside allows water to come in below the skimmer, and anything that's floating on the surface will get trapped. So mud and debris do not get to the outlet. Because it is below surface, it will continue to work in mild frozen conditions up to a couple of inches of ice. It is also a cost-effective product. The engineer should specify the size and orifice for the basin. We have 5 models to choose from with simple cost-effective conversion kits allow the weir size to be easily changed. So this is a template here, and it's a little hard to see, but there's a orifice plate within the skimmer. This hole in the middle goes over this little nub to hold them in place, and you simply rotate the plate to the desired size that goes through the pipe outlet. So it's hard to see there, but that's a 3/4 inch hole on our 2-inch skimmer, where you would have an option for a 1.5 inch, 3/4, 1 inch, or 1/2 inch, depending on your preference. Each model of skimmer we have provides from 3 to 5 flow rates with each device, and all of our flow rates are third-party tested to verify flow rates and drawdown times. Coming soon is our new 6 and 8-inch models. They will be available in June. They include a new custom molded float that's been designed to make these virtually unsinkable. They have built-in handles around the perimeter to make it easier to carry, and also the skirt will be attached to these handles around the perimeter to again provide that debris guard to make sure water comes in from below the surface. Third-party testing is expected to be completed this month with a anticipated shipping by June of 2020. Thank you for watching. This was the introduction to skimmer sediment basins. We do offer continuing education credit To receive that credit, simply email us at info@rymarwaterworks.com. We will send you back a short quiz just to confirm you have watched the presentation. Once you return that to us, we will send you a certificate for 1/2 hour of credit for this presentation. If you have any questions about incorporating skimmers into your design, or any questions about the Marley float in particular, please do not hesitate to reach out to us. We'll be more than happy to talk to you and assist in any way possible. Thank you again.